Our previous LS wiring harness videos covered routing and mounting, harness modifications, fuse relay box modifications, and external connections. But there are still things that anyone doing a similar project needs to know, things I wish we knew much sooner. That's what this wrap-up video is about. Let's get started. The harness wiring modifications video should have included this tip. The vehicle speed sensor, or VSS for short, sits near the tail end of the transmission. Out of the box, the LS3's wiring harness came with the wrong connector for the vehicle speed sensor, so they included an adapter cable that they call a jumper harness. We weren't okay with that, so we cut out the middleman connector, greatly shortened the cable, and soldered the connections directly. In the harness connections video, I promised to give more details on actually using the User Outputs Bulkhead Connector, so here goes. It's an Aptiv 12-pin female GT150 series connector. This is the only connector on the engine harness where you have to assemble your own mating connector. You need a 12-pin male GT150 connector, pins, also called terminals, and seals. The instructions say these are available from your dealer, but my local Chevy parts guy just gave me a deer in the headlights look. We ended up buying them on eBay. With the right parts in hand, building a mating connector for the User Outputs Bulkhead Connector requires 8 steps per wire, which sounds like a lot but really isn't. First, you have to remove a little silicone plug from the position you want to use. Note that the pin positions in the EROD instructions are for looking at the rear of the harness connector or the face of the male connector you are assembling. If you are looking at the face of the harness connector, the positions are mirrored. The second step is to strip about 1/4 inch of insulation off the end of the wire. Third, twist the strands so they stay together. Fourth, slide a seal onto the wire, ribbed end first. Fifth, crimp a terminal onto the wire. Sixth, the terminal must be crimped to hold but not crush the silicone seal. Seventh, the terminal should be slid into the correct position in the connector. The eighth and last step is to grab the terminal from the other side with needle nose pliers and pull until it locks into place. There's a lot of good information coming from the User Outputs Bulkhead Connector. Without changing anything, you should be able to drive a tachometer and speedometer, as well as oil pressure and vacuum gauges. There's also an empty pin available where you could route the output from the engine coolant temperature sensor. Before you buy gauges, I recommend asking the manufacturer if you can use the stock engine sensors. Don't just assume that it will work. The harness routing video mentioned the OBD-II connector being depinned to pass through the firewall. Reassembly is very straightforward as long as you have pictures or notes on where each pin goes. Each pin is pushed into position until it clicks. After all pins are reinstalled, the blue upper and lower pin locks are pushed into place until they click. The User Outputs Bulkhead Connector includes a GMLAN high-speed data bus that outputs a continuous stream of ones and zeros, digital information about the engine, including RPM, temperature, etc. It relies on differential signaling, so the voltage difference between the two wires is the only thing that matters. If both wires are the same voltage, it's interpreted as a 1. If the plus wire is 2 volts higher than the minus wire, it's interpreted as a 0. Both wires are required. There's no such thing as one-wire high-speed GMLAN. The User Outputs Bulkhead Connector has both GMLAN pins labeled incorrectly. Pin A is actually GMLAN High Speed Plus, and Pin G is actually GMLAN High Speed Minus. The GMLAN High Speed Bus is General Motors' version of a CAN bus. The GMLAN signals on the User Outputs Bulkhead Connector are also routed to the OBD-II connector. OBD-II Pin 6 is connected to User Output Pin G, and OBD-II Pin 14 is connected to User Output Pin A. GMLAN high-speed buses are supposed to have a 120 ohm resistor between the two wires at both ends. They're called termination resistors, and they absorb electrical energy that would otherwise be reflected. It's like putting a sandbag at the end of a shooting range instead of a rock wall. The engine control module, or ECM, has the 120 ohm resistor it is supposed to have. But since the bus is not connected to any other device, connectors don't count, there's no 120 ohm resistor at the other end of the bus. I thought maybe scanners included a termination resistor, but my Actron scanner doesn't have one. The bus may work anyway, but if you're having trouble getting reliable communication, you could try adding a 120 ohm resistor near the OBD-II connector as required by the GMLAN spec. What can you do with the GMLAN bus? At one point, we were planning to use it to inform our Dakota Digital VHX gauges. But according to Dakota Digital, their bus interface module, or BIM, would have to be disconnected anytime a scanner was connected to the OBD-II connector. That was a deal breaker for us, so we didn't use Dakota Digital's BIM or the GMLAN high-speed bus. The wiring harness includes 3 terminals that are supposed to be bolted directly to the engine. For each terminal, we used a star washer between it and the engine. The teeth on the star washer bite into adjacent surfaces and make a better electrical connection. On the outside of the terminal, we put a flat M10 stainless steel washer to help a stainless steel M10 by 20 bolt spin without spinning the terminal. We had to provide the wire for many things: battery cables, the starter cable, the electric fuel pump, and 2 electric fans. There's no need to guess what size cable you need. Here's an example of using an online calculator to determine the best gauge for fuel pump power. 13.8 volts is what you would find at the alternator or a fully charged battery. 15 amps comes from the fuel pump's instructions. That's the maximum current the pump can draw. If the instructions don't say, look for the rating of the recommended fuse or ask the manufacturer. Using a measuring tape, we came up with a quick and dirty estimate of wire length, added several feet to be safe, and got 20 feet. Remember that the goal is to have at least 12 volts at the destination under worst case conditions. Most of the time, conditions won't be worst case. In this example, I would choose 14 gauge wire. There's less than a 1 volt drop, and going with a heavier gauge would cost more, add more weight, be harder to route, and be harder to terminate at both ends. I strongly recommend against buying off-the-shelf battery cables at your local auto parts store. For less money, you can buy a cable online that is the length you want, the color you want, red or black, the gauge you want, and with the exact style of terminal on each end that you want. We bought 4 cables from Battery Cables USA and are super happy with them. This concludes our 5-part series on wiring an LS crate engine. Is there something else you'd like us to cover? If so, please let us know. Comments and questions are always welcome, and they help other viewers. Thank you for watching.